In this video, I'll be helping you with the math topic called solving an equation algebraically when the variable appears on both sides. We'll be using this example taken from the OpenStax College Algebra textbook, which has us solving this equation, which does have the variable on both sides of the equal sign. And in a previous example, we were given these how-to steps where we were told that we could add, subtract, multiply, and divide as long as we do so on both sides of the equal sign, how to get rid of parentheses with distribution, our goal of isolating the variable, and how to remove a coefficient in the final stage, and that we can use these with no set order depending upon what's given. So in this example, we can follow these steps. In seeing these parentheses in this example, I know I can use distribution to remove those parentheses. Starting on the left-hand side, distributing this 4 gives me a 4 times x, or 4x, and a 4 times minus 3, or minus 12. Bringing down the rest of the left-hand side, moving to the right-hand side, I can distribute this minus 5, giving me a minus 5 times x, or minus 5x, and a minus 5 times 6, or minus 30. So we've removed those parentheses, and from here I can see that I do have some like terms on the left and the right that I can combine. On the left, a minus 12 and a plus 12 will combine to 0, leaving me with just the 4x on the left-hand side. On the right-hand side, 15 and a minus 30 are like terms. So bringing down the minus 5x, the 15 and minus 30 combine to be a minus 15. From here, I want to isolate the variable on one side of the equation, so I'll need to move one of these variables to join the other. And using addition and subtraction to do so, I can add 5x to the right-hand side, as long as I do so on both sides. So add 5x to the left-hand side. This will cancel on the right and give me a 9x on the left. And now that those x's have canceled on the right, I have just that minus 15. And now to remove that coefficient in front of the x, I can use division as long as I do so on both sides. This will cancel on the left, leaving me just the isolated x. And then on the right-hand side, this fraction will simplify since both the numerator and denominator are divisible by 3. 9 divided by 3 is 3. 15 divided by 3 is 5. So we are left with negative 5 over 3. We have isolated the x and simplified as much as possible. So this is our solution.